This video clip is part of the EPFL introductory course on information computing and communication. It is the third and last one in a set of clips building the introductory lesson to this course. It outlines the content of the rest of the course. As underlined in the previous two clips, information computing and communication are the three pillars of this course. In the EPFL ICC course, these subjects are covered in 13 two-hour lessons building three modules. The first module explores the foundation of computing while providing a first feel for the representation of information. The second module explores the foundation of communication while diving deeper into information coding. The third module explores the architecture of computers, their storage, and the communication networks that link them. The four lessons of the computing module lay the foundations for processing information. The first lesson introduces the fundamental notion of an algorithm. The second lesson maps out some of the main strategies for computing. The third lesson sketches the theory of computation. And the fourth lesson gives a first quick view of information representation inside computers. The four lessons of the communication module lay the foundations for transmitting information across networks. Lesson 1 explains the notion of sampling an information signal to encode it for digital transmission. Lesson 2 explains how to reconstruct such a signal from its transmitted samples. Lesson 3 introduces the notion of information entropy, which measures its complexity and is the basis for encoding it. The fourth lesson explains how information can be compressed with or without loss of precision to save transmission time or storage space. The 5 lessons of the systems module summarize how computers function. The first lesson introduces the main building blocks making up the architecture of the computer. The second lesson discusses the fundamental notion of hierarchies in computer storage. The third lesson sketches how information can be stored into and retrieved from file systems and databases. The fourth lesson focuses on basic computer network principles. And the fifth lesson concludes the course by underlining the vital need for and foundations of computer security. This slide refers to the first module of the course. The first lesson will introduce the notion of algorithm by showing how to search for or sort information, or how to compute the shortest path between 2 points. The second lesson will explain some of the basic algorithmic techniques for computing, such as, for instance, iteration, recursion, and hierarchical subdivision of problems into subproblems. The third lesson will explore the limits of what is computable by an algorithm and what is not, following a theory due to Alan Turing and his abstract universal tape machine, which underlies the theory. The fourth lesson will then show how information such as numbers, characters, images, sound, video, etc. can be represented inside computers. Talking about computing, this semi-logarithmic graph is another illustration of Moore's law showing hyper-exponential growth in the amount of computing power that could be brought for $1,000 since the beginning of the 20th century. One can see that starting from mechanical computing machines, then electromechanical ones, onto electronic ones using tubes, then transistors, and eventually integrated circuits, $1,000 allowed buying a computing power that evolved actually a little faster than exponentially, since the historical points land on a curve that curves slightly upward on the semi-logarithmic graph. This slide now refers to the second module of the course. The first and second lessons of this module will introduce the notion of sampling any signal to store or transmit it, and then reconstructing it from its stored or transmitted representation. The third lesson will discuss the notion of information entropy due to Claude Shannon, which measures the complexity and thus the volume that an information requires for its representation and transmission. The fourth lesson will finally discuss how a sampled information may be compressed with or without loss of precision to limit its volume and thereby save space for its storage or time for its transmission between computers. Talking about volume of information, this slide shows how all of humanity's information is moving online, where it evidently becomes available for processing. More specifically, one can see that while the volume of information generated in the world doubles every year, the portion of this information that ends up digitized and stored in cyberspace every year is multiplied by 4, so that in a not too distant future, all of the world's information might find itself online somewhere. This next slide refers to the third module of the course. Its first lesson will introduce the main building blocks of a computer according to an architecture due to John von Neumann. It will focus more specifically on the operation in its processor, which is at the heart of the computing process. The second lesson will then discuss the notion of memory and storage hierarchies in a computer, from its registers and cache memory at the heart of the processor through its main memory onto its peripheral storage devices such as hard disks and magnetic tapes. The third lesson will next focus on the structure and organization of information stored in files and databases on hard disks or magnetic tapes. The fourth lesson will finally cover the implementation and operation of communication networks, tying computers and their users together. The fifth lesson will wrap up the module in the course by discussing the key issue of computer security, such as the need for protecting privacy and the principles of cryptography, authentication, and access control inside computers. Information storage, it is interesting to underline with this slide that early information support devices from ancient history have nothing to long for compared to modern devices in matters of reliability and lifetime. While papyrus rolls have largely disappeared, no modern storage device is able to resist the passing time, as do engraved hieroglyphs of the Rosetta Stones. Even books, newspapers, films, prints, and vinyl discs of the past century are more reliable and durable than any electronic storage device of the digital era. And even if some digital storage devices of the past did resist the aggression of times, they all become unreadable after a few years, simply for lack of hardware and software required to read them, because digital technologies evolve and pass away so fast. To wrap up, this introductory lesson has tried to show the past exponential developments of ICC technologies. The lesson has also tried to underline how ICC have become a central discipline on par with languages and mathematics, and how it has become essential to all other disciplines, as well as to the development of the service economies of our tertiary societies. By focusing on the architecture and operation of computer systems, the ensuing video clips in this series cover the content of the 5 lessons of the last module of the EPFL ICC course. The first one introduces the main building blocks making up the architecture of the computer. The second one discusses the fundamental notion of hierarchies in computer storage. The third one will sketch how information can be stored into and retrieved from files and databases. The fourth one will focus on basic computer networking principles. And the last and fifth one will conclude the course by underlying the vital need for and foundations of computer security.